Girls, over the page, find the value of the polynomials below. I've got two unknowns. Now, the problem here is the A, does it match with the 3 or does the A match with the 2? So, I have to work out which angles match which, and that's your use of geometry that will help you. Girls, I'm going to put a dot here. That dot, that angle equals which angle? Vertically opposite, good. But the main thing here, I'm going to put an arc here in that top right-hand corner. Can you see what I've done? Girls, parallel lines, what have you got? Yes, good. Girls, why does this match? Why does that match that? Alternate. Do you see? And if I put a little cross here, that matches this alternate. Now I know exactly which sides match which. Are we okay with this? Yeah. All right, this one's a little bit tricky, all right? Looking at this, girls, can you see a definite pair that matches? A definite pair. 4 and 16 match because cross arc. So 4 over 16 are a definite match. Tell me what you think A matches with. Now A is between dot and arc. Fantastic. A and 2. And then, therefore, the 3 and the B match. So, I've got circles, squares, and underlines. Now I know what matches what. So, I want to find A first, okay? I'm not going to do scale. I mean, I could do scale factor. Just look at it, girls. Look at the 4 and the 16, and you tell me, just in your own words, about the size of this bottom triangle compared to the size of the top one. It's 4 times bigger. Look, 4 to 16. That's when scale factor is good. You don't have to set it all out. You can clearly see that the bottom triangle is 4 times bigger. Can you see that? So if 2 and A match, you tell me what, and A is in the bottom triangle, tell me what A is.
8.
Yeah, it's 4 times bigger. That's 8, and this is, B is 12. But if we don't want to do it like that, see, some people can see that straight away, and that's okay. So I'm going to do a little thing on that the bottom triangle is 4 times bigger. How can I tell? See, this is where sometimes it's best not to use rules. If you want, you can go the scale factor. You know how it's the second object over the first? It's 16 over 4 are matching sides. We're getting a scale factor of 4. Now, I know that the 2 and the A match. A is 4 times bigger than 2. So A is 2 times 4 is 8. I'm going to do the equations in a minute. And B is 4 times bigger than 3, which is 12. That's a common sense approach to do with this problem. The only time I'd use that if you can clearly see, if you've got whole numbers, this triangle is 4 times bigger than that one. Okay? To go from the top triangle to the bottom, we're clearly timesing by 4. There's your instruction of what to do. That's the scale factor without writing all the theory. Okay? All right. Question 10. Going to do this one using the equation setup. All right? The only time you'd use this common sense method, nice, easy whole numbers. All right? Remember, similarity, one object's just an enlargement of the other. Okay, we're going to draw this diagram. Now, you have to think of when the sun shines, apart from midday, in the afternoon, where the shadow forms. So, if the sun is here and you are standing on the ground here, where does the shadow form? In front of you or behind you? Girls? No, it's behind you. So here's the sun shining on a person or a tree or whatever. The shadow will be behind you. Where is the sun in the middle of the day? Above you. Where is the sun in the afternoon? Down by the horizon. That is why are shadows longer at sunset? See, girls, when in the middle of the day, the sun's up here shining down. Basically, there'll be no shadows. As the day goes on, look, the sun's moving down the shadow becomes longer. Sorry, it's got to go over this person's head. Of course, the sun's not that low in the sky. But the more the sun moves down like this, the shadow becomes longer. The shadows are on the ground. Do you get that? Okay. Why are shadows longer at sunset? Shadows are longer. The sun is shining its rays like this now. Do you get that? All right. Yeah. The sun is lower in the sky. Sun shines at a at an angle, etc. Yeah, it's closer to the ground. That's right, and the shadow will become longer because it's now. Shh. So girls, here there's no shadow. Here there's only a little shadow. Look, here there's a bigger shadow. Can you see the shadows forming? Girls, it happens. Just think the sun, the shadow's behind you. If you're standing under a tree and the sun's over here and this is the tree, you're going to stand on this side of the tree for shade, not in front of the tree, directly in the sun. Okay? Now let's draw this diagram. At sunset, a mountain of height 1,500 meters casts a shadow of length 6 kilometers, while a television tower throws a shadow of 15 meters. Look at the two shadows. It's at the same time of day. Which object is taller? At sunset, a mountain of height 1,500 meters casts a shadow of length 6 kilometers, while a television tower casts a shadow of 15 meters. Which one's the longest shadow, the 6 kilometers or the 15 meters? So here is my sun. Here is my mountain. All right, that casts, see the sun shines down here. That's my mountain. It's 1,500 meters high and the shadows are always on the ground. This is 6 kilometers. Now, but the television tower, I'm going to draw it in here. The television tower only casts a shadow of 15 meters. Now, it's 6 kilometers from there to there. Inside this same triangle, girls, I am doing the television tower. Can you see this? Cast a shadow of 15. That length just there is 15 meters. 1 minute. And I'm going to call that T for television tower. Wait, we have to assume these are at right angles. Okay, I've got two triangles. See this angle in the corner? It's common to both triangles. I'm going to draw the two triangles separately. I've got my 1,500 meter high, 6 kilometers. I've already got a problem there. That's my first triangle. My second triangle looks like this, 15 meters, television tower. Girls, what's my problem in here? What do I need to change? Change this to meters. Right, set up our equation. Set up the equation now. What over what? What over what? What do you look for first? The unknown. T over 1,500. I'm going that way. Equals, come on, that over that equals 15 over 6,000. Okay, girls, the two triangles, when they're shadow ones, they're drawn inside each other. This angle in the triangle is the same down there. So the unknown, T over 1,500 equals 15 over 6,000. How do we solve it? T is 15 over 6,000 times 1,500. Whatever that equals. The tower is 3.75 meters. Okay? It's a small one. Okay. Continuing with exercise 302, similarity and scale factors. We're on our second video and we're up to the second last page, question 14. So Anthony stands at point A here on the diagram so that he is in line with the pier. So basically if he looks across there, he can see the pier and the tree. They are in a straight line, okay? So he is in line with the pier and the tree on the opposite side of the canal. This is a canal, it's water. He then takes measurements of 15 metres, so his perpendicular distance to the canal is 15. And also this distance, of course he can't measure across the water, but he can see how far away he is from the canal, and he's measured this distance there as well. So this is 15 and that's 24. So the distance of the tree, also on land he can measure, the distance of the jetty to the tree is 150. It says use two similar triangles to find the width of the canal. When we use similar triangles, you've got to know which angles are matching up with which. I know that we've got a right angle here and a right angle there. See this little angle here with a dot? Do you know which angle would match it up in this triangle? Is it the one there or the one here?
The top one, the really top one under the tree.
Okay, girls, do you remember alternate angles? Just looking here, if you've got parallel lines. Not alternate, but corresponding angles. So for example, the angle down here matches with the angle there. They're called corresponding. The angle, say here in pink, matches with that angle there, corresponding. If I see, because I've got a horizontal and a vertical and a horizontal and a vertical, these two lines are parallel. So it is like the F angle, and I've got this and I've got this. It's like an upside down F. So this dot here is actually the same as that dot there. They're the corresponding angles. Okay? It's also because this is a straight line. So it's like we've got, you know, the transversals. If I continue this across, and if I continue this across, and this one down, it's like I've got the parallel lines. I've got the upside down backward F here. Look. Can you see it? It's the, if I continue that across, I've got an upside down backward F. So this dot here is the same as that dot there. They're the same angle. All right, here. So I've got a small triangle and a big one. I know I've both got the right angles, but I need to see if this angle here matches with that one there or with the one up the top. Because I've got a right angle here and a right angle there, these two lines are parallel. So that means I can do alternate or corresponding. So there's no point doing a Z angle here. I'm going to draw in the upside down backward F. F is corresponding, right? Can you see it?
Yes.
There, those two are the same. Upside down, backward F. So what I'm going to do is draw these two triangles separately over here. Here's the first one, 15, 20, with the dot there. Oops, you can't see it. And here's the other one. All right, dot, right angle. What should I mark on this? So I drew this, sorry, that's 24, sorry. 15, 24, right angle and dot. What do I put here? Anyone?
150.
150. And I need to find the width of the canal. I'm going to call it W. That is the width of the canal. So we've got two similar triangles. The thing is, you're going to have to know which angles match with which. Now we set up our ratio statement. I don't want to do scale factor. Obviously, the second triangle is bigger than the first, but remember, what I'm going to do, I'm going to put W, what's its partner? What's the matching side to W in the other triangle? 15. And I've got 150 matches with what? Good. So it's a good idea to put circles and underlines, visually match them up. So now we always put our unknown first. So how am I going to set up this ratio statement with an equals? W over 15 equals, so W over 15 equals 150 over 24. If I'm going from right to left, W over 15 equals 150 over 24. I need to make sure I know which sides are corresponding, the matching ones, then I need to do them in the same order. That over that equals that over that. I'm going from right to left equals right over left. Got it? Right over left equals right over left. Now, how do I work out what W is? What do I do with that divide by 15? Times by 15 on the other side. Okay, so the main thing here was to know that you've got similar triangles. It does say use two similar triangles, but to know that this angle there matched that one with that pink upside down back to front corresponding F. Okay, so what do we got? What do we have? Sorry. 93.75 metres. Did anyone else get that? In here it says a fireman's ladder, which is obviously this, reaches 12.5 metres up the building. So it's that height there. The ladder is propped up by a support. Can you imagine that this would buckle? It wouldn't stay straight. So here's the support there. It's propped up by a support placed 5.4 metres from the building and 3.2 metres from the base of the ladder. So something like that big, if you didn't put a support there, it would go like this as soon as people start standing on it. All right? It would buckle. Okay? So here's the support. It's 5.4 metres from the building, 3.2 metres from the base of the ladder. What is the length of the support? So this, I'm going to call this X. What's the length of the support? So we've got similar triangles. What I'm going to do, see how I've got the little triangle and I've got the big triangle? See this angle down here in the corner? It's the same angle. That little dot belongs to both triangles. What sort of angle do I have here, girls? Great. And what about here? It's also a right angle. That support would be vertical. So I've got two triangles. I've got the small triangle here. Now, again, just going over it with your pen, there's a little dot there. And if I look at the big triangle, there's a dot there. So that angle in the corner is the same. Now, I need some measurements on the small triangle. What do you think we have down here? And what do we have here? So that's the little triangle done. What about the big triangle? What should I do?
5.4.
No, big triangle's all the way across there.
8.6.
Very good. 8.6
And 12.5.
and 12.5. Now, why do I have two similar triangles? Girls, similar triangles, the angles in them are the same. See how I've got right angle and I've got the dot. Let's say that was 90 and that was 30. The other ones would automatically be 60 because, 180 degrees in a triangle. So these two angles are the same. Those two angles are the same. By default, like what's left over, these two angles there have to be the same. Do you get that? If they're the same and they're the same, then the top ones have to be the same because all triangles add up to 180. So now I'm going to set up my statement to work out my missing side. So which one am I trying to find? X. Let's circle the pairs. X goes with what? X and 12.5 are a match, and 3.2 and 8.6 are a match. How do I know? Right angle dot, right angle dot. So you always put the one that you want to find first, which is X. So I'm going to go this way. X matches with 12.5. So X over 12.5, that's how you do it, equals what over what? So that over that equals 3.2 over 8.6. And now I just solve my equation by getting X on its own. It says X divide by 12.5. The inverse operation of dividing by 12.5 is to times by 12.5. Okay, so rather than working out scale factor, it's easier to just set up this statement. X over 12.5 equals 3.2 over 8.6. Now you might ask, how do I know which way to go? You always put your unknown first and on top. So X over 12.5. I don't want to see 12.5 over X. All right, unknown first on the numerator. Over 12.5 means I'm going right to left. Equals 3.2 over 8.6. that support, 4.651. To 1 decimal place, 4.7 metres. Okay. Yeah. Leela, whatever her name is, stands 32 metres from the flagpole. So that's her direct distance to the flagpole. And it moves, she holds a 30 centimetre ruler up, girls. That's, you know that trick? She holds a 30 centimetre ruler up in front of her and moves until it appears to be the same height as the flagpole. You know how people hold on to objects, you know, trick photography, that sort of stuff? So she's got a ruler out in front of her. It's a 30 centimetre normal ruler. And until it appears to be the same height as the flagpole. If this occurs when the ruler is 70 centimetres from her eye, how tall is the flagpole correct to 1 decimal place? So I'm going to draw the two triangles. So this is the small one, this is the large one. Please be careful of where those distances are, because this is the ruler, it's 30 centimetres. Where do I write the 70 centimetres? On one of the side lengths or through the middle? It's through the middle. So this is 30 centimetres. The distance from her eye to the ruler is 70 centimetres. It's not that distance there or there. It's the distance, the perpendicular distance. Now, this is where she's standing as well. We know that the distance from there to the flagpole is 32, but it's 32 metres. So we're going to have to change some units. And this is the height, or the height of the flagpole. So the question is, how high is the flagpole? Now, girls, I would be changing the units. Now, do you want to change them to metres? Like your flagpole, do you think it's going to be in metres or centimetres, the answer? For the flagpole, the height, metres. Because she's got a little ruler in front of her, and change the units of these to metres, because this answer is definitely going to be in metres. So instead of using 70 centimetres and 30 centimetres, we want them both in metres. How many centimetres in a metre? 100 centimetres in 1 metre. So what do I write here for the length of the ruler? 0.3 is this distance, and this one is 0.7, and that's in metres. Now we can set up our statement. Let's circle what matches with what. The H, where's its partner? And the 32 metres, what's its partner? 0.7. So we always put what we want first. So H, please do circles and squares. It's so much easier. Circles together, squares together, or rectangles. So how do I set up my statement? Always what I want first. H over 0.3 equals, so H over 0.3 equals 32 over 0.7. So H is 32 over 0.7. What do I do? Times or divide by 0.3? Times 0.3. It's H divide by 0.3 on the left. It'll be that times 0.3 on the right. So therefore H is 13.7 metres.